Neptune, the eighth planet from the Sun, captivates with its striking blue hue and dynamic atmosphere. Known for its extreme weather, it is distinguished by the fastest winds observed in the solar system, adding to its mysterious and distant nature. The atmosphere of Neptune is predominantly composed of hydrogen and helium, with a notable presence of methane that imparts the planet's characteristic blue color. This composition creates a layer of highly reflective clouds, hovering above a deeper, thicker layer of icy materials. For the sake of this video, we've crafted a special spacesuit designed to withstand the extreme conditions of Neptune. This innovative suit must brave temperatures as low as -200 degrees Celsius and endure pressures vastly exceeding those found on Earth. As one begins the descent into Neptune's upper atmosphere, there's an immediate encounter with increasing pressure and a sharp drop in temperature. This initial phase challenges the integrity of the specially designed suit, testing its limits in an alien environment. Among the captivating visual phenomena in Neptune's atmosphere are the swirling methane clouds. Even more intriguing is the possibility of witnessing diamond rain, a phenomenon where methane under extreme pressure transforms into diamond, falling through the atmosphere like glittering rain. As we transition through Neptune's atmospheric layers, the composition shifts noticeably. Higher layers predominantly contain hydrogen and helium, but as we descend, methane becomes more prevalent. This shift impacts the atmospheric color and density, creating a surreal environment that changes before our eyes. Descending deeper, we encounter Neptune's notorious supersonic winds. These winds, exceeding speeds of 1,000 kilometers per hour, challenge the integrity of our advanced spacesuit. Amid these fierce conditions, we might glimpse massive storm systems like the Great Dark Spot, a storm rivaling Earth's hurricanes in intensity. The pressure in Neptune's atmosphere intensifies as we go deeper, reminiscent of the pressures found in Earth's deepest oceans. Temperature variations become more pronounced with depth. Initially, the descent is marked by a steep drop in temperature, but paradoxically, deeper layers might exhibit a slight increase due to the compression of gases and residual internal heat from the planet. Classifying Neptune as an ice giant reveals its mysterious internal structure, primarily consisting of ices like water, ammonia, and methane. This classification hints at a composition vastly different from the terrestrial planets, comprising a complex interplay of high-pressure ice and gas envelopes. Speculative chemical reactions in Neptune's extreme conditions could produce vibrant auroras or unexpected energy discharges. As these reactions unfold, they might emit unique colors or flashes, detectable even through the dense methane clouds, hinting at the complex chemistry at play. Neptune's gravity, surprisingly similar to Earth's, influences how objects and hypothetical explorers move through its atmosphere. This gravity would assist in stabilizing descent trajectories, making navigation slightly more predictable despite the turbulent winds and swirling gases. Descending deeper, the atmosphere's dense layers might carry sounds of whistling winds or the distant rumble of storms. These sounds, muffled by the thick gaseous environment, could provide auditory clues to the atmospheric conditions and movements within this alien world. Imagining life in Neptune's extreme conditions leads to fascinating possibilities. Microbial forms or more complex organisms might exist, thriving on chemical energy from the planet's atmosphere, hidden in the dense clouds or floating in the upper layers where sunlight still penetrates. Reaching a hypothetical midpoint in Neptune's atmosphere presents a brief respite where conditions momentarily stabilize. This zone, while still harsh, offers a pause in the relentless pressure and temperature extremes. As the journey progresses towards Neptune's core, the challenges intensify. the surrounding gases thicken and temperatures plunge further. Theories about Neptune's core suggest a fascinating mixture of rock and ice, compressed under unimaginable pressure. This composition could offer clues about the planet's formation and evolution, shedding light on similar processes across the solar system. As we hypothetically approach Neptune's core, speculation abounds about its composition, potentially a dense mix of rock and ice under unimaginable pressures. This enigmatic center might present a state of matter unique to the intense conditions of ice giants. Reflecting on the journey through Neptune's turbulent atmosphere to its mysterious core offers both scientific and imaginative value. This venture, though theoretical, expands our understanding of planetary science and challenges our perceptions of what conditions celestial bodies can harbor. Stay informed, stay curious, subscribe for more. Thank you for watching.